Okay, so we've been doing the videos showing how to work through this Khan Academy Algebra Quadratic Functions and Equations unit. This is our 6th video. So we're going to do the quadratic word problems, and I'm going to remind you that, not that one, this one, there are basically 4 points that they are going to ask about. Where does it start? Where does it end? How high was it at the highest point, or how low was it at the highest point? What's its maximum or what's its minimum? And when or where was the maximum or minimum? Those are the 4 kinds of questions you're going to get for quadratic word problems. So let's read. I haven't read this one. And just, kind of get random questions from Khan, so not like I'm prepared. Amir stands on a balcony and throws a ball to his dog, who is at ground level. So I'm going to kind of sketch this out. So here's a balcony, and here's Amir, and here's Amir's dog. You just love me. I'm just like a great artist. Okay. The ball's height in meters above the ground, x seconds after Amir threw it, is modeled by this, and we can see that the leading coefficient is negative. So is it going to open up or down? It's going to open down. That makes sense, because if he's throwing a ball, he's going to throw the ball. It's going to look like that. But what we need to know is this is a distance, and our graph is not going to be by distance. Our graph is going to be by time. Okay? Our graph is going to be height by time. So, what is the maximum height that the ball will reach? Well, what is that maximum? Let's look back. Whoop, not that one. Look back here. That's the vertex. So we need to find the vertex, and what is the maximum height that is going to be the y value for the vertex. So we need to find the vertex. And we know that this is y equals negative x plus 1 times x minus 7. That means it's going to look like that. Okay, it's going to open down. And we need to find these 2 points right here so that we can get that vertex. So we're going to find the x-intercepts just like we did in the last video. So x plus 1 equals 0, or x minus 7 is equal to 0. So x is equal to negative 1, or x is equal to 7. And we want to find we're not actually interested in those, but we want to find the midpoint. We want to find the vertex, so that's in the middle there. So we're going to say the x for the vertex here is negative 1, negative 1 plus 7 over 2, which is equal to 6 over 2, which is equal to 3. So this is at 3. And then it doesn't ask us at what time. It's at 3 seconds, but it doesn't ask us what time. It asks us, how high, right? What is the maximum height, right? So then we have to plug that, we have to substitute that 3 in. So we know that the y is equal to negative x is 3. So then y is equal to negative 4 times negative 4. And then you see that 4 and negative 4. If you don't see that, you know you did something wrong. So y is equal to 16. So the height, maximum height, is 16 meters. Man, he throws high. Okay. Let me erase here. Okay, let me figure out how to not make that gray. The number of mosquitoes in Brooklyn, in millions of mosquitoes, as a function of rainfall in centimeters, is modeled by, this is really similar to what we did a couple of videos ago. Here it is, negative x times x minus 4. So that's going to open down. right? I know it's going to open down. And if I question is what amount of rainfall results in the maximum number of mosquitoes? So again, that's what amount of rainfall, how much rainfall, where do we get the highest point? So what we want is we want that x value right here. Okay. So we're going to find the x-intercepts so that find the x-intercepts in these two places. So we can figure out where what the x value of the vertex is. Okay, so I know that either negative x is equal to 0. I could say x is equal to 0. I don't want anybody to get confused. Or x minus 4 is equal to, 0. So if I want to find the x-intercepts, right? So x is equal to 0 or x is equal to 4. Okay, so those are my two x-intercepts, and now I want to find the x of the vertex, and that is going to be the average of the two, which is equal to 4 over 2, which is equal to 2. So what does that look like? Let's just try and draw it out and see if we can make some sense of it. And I want to, just because I want to figure out what that y value is, so we can model. We don't need it for the answer here, and if you are doing this on a test, don't waste your time. But I think it's useful here. So negative 2 times 2 minus 4 is negative 2. So that's our y is 4. So it's going to be up 1, 2, 3, 4 million. Our maximum is going to be 4 million. And our maximum is going to be at this point right here. And then our zeros are in these two places. So our parabola looks like this. It looks more like a pyramid than a parabola, but that's why we have graphing calculators. So you can see when the rainfall is 0, we have 0 mosquitoes, and when the rainfall is 2 centimeters, we get 4 million mosquitoes, and then it goes back down until we hit there. But we can see the answer we want is what amount of rainfall results in the maximum number of mosquitoes, and that is 2. Let me delete here. A certain company's main source of income is a mobile app. Well, that sounds like one we did before too. The company's annual profit in millions of dollars as a function of the app's price in dollars is modeled by blah, 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 blah. What would be the company's profit if the app price is $0? So again, if it's $0, when we start off at 0, how much money do we make? And we do that by substituting. So we don't have to find anything here. We can just substitute where x is equal to 0. So the profit when we charge 0 is equal to negative 2 times 0 minus 3 times 0 minus 11. And that is equal to negative 2 times negative 3 times negative 11. And then these two negatives, negative times a negative is a positive. 2 times 3 is 6. 6 times negative 11 is negative 66. So we're going to lose $66 million if we don't charge for it. All right, and we have one last one I'm not going to erase because it didn't use very much. Anna dives into a pool off a springboard high dive. Her height in meters above the water, x seconds after diving, is modeled by... How many seconds after diving will Anna hit the water? So she is diving. Let me kind of draw that out like we did with the guy and the dog here. So here's Anna. Anna looked just like the other guy. What was his name? Luis. And she's going to dive off into a pool. And here's the pool. And she's going to dive off into the pool. And again, be careful that we are not talking about this shape here. We're talking about how high she is over time. So it's not how far is she going. It's going to be time and height. Okay, a lot of kids don't really understand. They think this is a parabola too, but it's not the parabola we're talking about. Wave my hands. These are not the parabolas we're talking about. Her height in meters above the water x seconds after diving is modeled by blah blah. How many seconds after diving will Anna hit the water? So what do we want to know? We want to know the end when y equals 0. So we want that x-intercept, and we want the bigger x-intercept. When does she hit the water? What time does she hit the water? That's when it ends. So let's look at the equation here. -5, x plus 1, x minus 3. So I know that it's going to look like this. Right? And I'm going to have 1x intercept here and 1x intercept here. So I know I want one of those. I need to figure out which one. But what I do know is that y is equal to 0. Doesn't want to undo. I'm not sure why. Or we got something going on here. There we go. Well, I appear to like hung or something. All right, I'll tell you what. I'm going to use my other drawing program. So x. There we go. Thank you. Okay. So we know that, let's try this again. X plus 1 is equal to 0, or x minus... It really doesn't like undo. That undo, it takes like a second. X minus 3 is equal to 0. So either x is, let's reuse this one, x is equal to -1, or x is equal to 3. So here it is, and I'm at either at -1 or 3. So I know that when she hits the water, it's going to be that bigger one, and it's going to be 3 seconds. And that's how we do quadratic word problems. Remember, your word problems will, like 99% of the time, ask you, where does it start? Where does it end? What's the highest point? Or when or where was the highest point? That's pretty much it. 4 questions. So you need to figure out which question they're asking, and then you can answer it.